All right, hello everyone. So a few weeks ago, we had a discussion about how to write computational essays and expositions. And somehow that turned into, okay, show us how you write one of these for me. So we have a whole bunch of people here, including many who are quite experienced at writing things. And let's see if we can talk a little bit about process for how to write one of these things and see how much people agree or disagree about what to do. So we're just talking the last couple of minutes. What on earth am I going to write one of these about? So I picked Boolean functions. So my topic is Boolean functions. Now, this is a subject that I know reasonably well. At least that is my theory. If I didn't know it well, I would have to have an interviewee to work with, because otherwise I don't know what I'm talking about. Okay, so what we're doing here. So the question is, so I need some kind of introduction. So I'm going to talk about Boolean functions. What are Boolean functions? That's things like and or and so on. And so the first thing to say is, what's the main point? And we have a function in the language called Boolean function, and I think what I'm going to be doing, so I'm just sort of thinking through, and I haven't thought this out previously. I'm thinking through what, let's see. So the basic point of a Boolean function is it's something that is going to take a bunch of Boolean variables. Okay, so okay. In typical mathematics, well, we got to have the idea of a function and then the idea of a Boolean function. The point of a Boolean function is that its inputs are combinations of trues and falses. So what's a little tricky is that people are used to the idea of f of x, or maybe f of x and y, but in a Boolean function, it's really very common to have p, q, r, s, many variables. So we kind of have to explain that. And then we have to, and why would we care about this? That's another thing we have to be able to say quite quickly up front. And then we might want to give an example, and of true and false and so on. All right. Anybody got any suggestions here? Or am I on my own?
Well, in your important principles of technical writing, you say to sell people on why the feature is important before diving into it.
Yes. And so I think well, what is the answer? Like I know Roger in his past life has analyzed fighter planes using Boolean functions and things. I think, let's see.
I think if you want to bring up, it's the foundation of modern technology, such as digital circuits.
Yeah, that's a fair point.
And Shannon came up with them to systematize designing switches, right? Meaning so phone switches, telephone switches.
Switching, we've got digital computers, digital electronics. In many situations, well, okay, so the question is, are we going for digital electronics, or are we going for the more theoretical true false type story? Let's see.
Concrete use case is probably easier to communicate.
Well, it depends who we're communicating it to. But yes. Okay, so maybe we want to say, I mean, the beginning should be something, and it's always difficult. The first couple of sentences are always difficult because they're where you're kind of saying what the big point is. And so at the core of computers and other digital electronics are circuits that implement Boolean functions. In a Boolean function, one gives a collection of 0, 1, or let's see, 0, 1. One gives a collection of the input to a Boolean function is a collection of values that can be either true/false, 1/0, on/off, etc. Its output in the simplest form, its output is a single such value. Now, again, okay, so what am I doing here? So one of the tricky things is an ordinary Boolean function of the kind that the Boolean function deals with has this feature that its output is a single value. But now I'm using the fact that I know that there's also reversible logic where you can have two inputs, like an AND is two inputs, one output. But I know that they're also particularly used in quantum frameworks, also two input, two output functions. So I'm trying to avoid just saying a Boolean function has one output, because in modern times, one often considers Boolean functions that don't just have one output. And so one of the questions is, how do you say that without confusing everybody? I mean, you can be very mathematical and say something like, it's a mapping from a set of this, that, and the other to the single function, but that wouldn't be the right thing to say. So you have to have some way to kind of give an indication of what's going on without saying the wrong thing.
I think it's pretty straightforward. A vector of functions is means a vector valued function, and that's used heavily in all these applications too, not just quantum computing.
Fair enough, but I'm just saying. Okay. By the way,
for an ALU, we had two 64-bit numbers in and a 64-bit numbers out.
Yeah, fair enough.
I mean, it has.
Well, but our Boolean function is a one output Boolean function, right?
Yeah, but that's like the primitive from which you build everything.
Right. Okay. Well, okay. But when we talk about a function, people's view of a function is more what you would see in calculus or something, where it's a function f of x and y. It returns one value. I mean, okay, yes, it can be a vector valued function, but in the simplest case, it returns one value. Okay, I'm having a difficulty with this first sentence. What is my difficulty? My difficulty is, for those of us who are old fogies, core was core memory. And it's a little bit weird to say that about computers here. See what I'm saying? So it'd be better to avoid that possible confusion and people saying, are you talking about core memory? What are you talking about here? Maybe at the heart of computers, and it sounds a little bit touchy-feely, but now here, in a sense, it isn't just electronics. It's probably okay. I mean, people know what a circuit is, even though, and people have some idea of what a circuit is, even though it doesn't necessarily the case that these things are sort of all kind of connected to feedback like a circuit does. But it's okay. Let's keep going. The input to a Boolean function is a collection of values that can either be Now, this might be confusing, but I think it's a useful thing to say, because otherwise people will be confused about, which of these. Okay, the input to a Boolean function in the simplest form, its output is a single such value. Okay, so now an example, a basic example of a Boolean function is and. Okay, so now we just say, now we would say, and of P and Q, or P and Q, or P and Q, is a Boolean function, is a basic, let's see, a basic example.
You're mixing ands and ors there. It's not clear if you're using Booleans in your English text.
Thank you. Yes, I was good catch. How do we deal with that? Okay, and P and Q alternatively written as we got another or here. It's going to be tough to put together this without a conjunction, which is also a Boolean operator. Maybe we drop that one there for now. And can you see how to do this, Eric? Can you see how to get rid of the Boolean thingy there?
Maybe you could just put the Boolean functions in a different font so it's obvious which one, or a bold or something, so it's obvious when you're talking about Boolean functions versus the English word.
Yes, well, they would naturally be in a different font. So, I mean, this will naturally be in
you could use a serial comma.
Horrible. We've already got commas running around here. By the way, how do we make this? So let me comment on this. This is going to be code, and we're, here, arguably we make that into code like that because we're already now talking about something which can be expressed in Wolfram language. And here again, arguably that's true, false, like that. That's 1, 0. Those are, Wolfram language things which can be written that way. And nobody's going to be confused by that. Nobody's going to be confused by seeing that in a different font, but yet it leads them into the idea that that's actually representable computationally. Okay, is and. So and PQ. So here, these should be in italics, and I'm not quite sure how to put them in italics. How do I do that, actually? Does anybody know? How do I?
If you use Control-9 for the whole thing.
I did use Control-9, but now I want to put those.
No, but for the whole
standard
expression.
I did use Command-9. Oh, Control-9.
Yeah.
What would that do?
Put some inline math.
Okay. That's not helping me because I want this to be in. I don't want that to be in the text font. You see what I'm saying? This isn't quite right.
Oh, if you
Yeah.
just want to make it italics, it's Command-I.
I'm well aware of that. Look, what we really want to do.
They used to
let
be
me
in a
show you.
different font, so I think that's some recent thing that they look in text.
Look. Here's what we really want, and we have a way to do this now, using the consumerized DocuTools. But this is the way to do it using our fancy DocuTools. Is to say template input. Oh, for goodness freaking sake! That's the right font, but it's gone crazy, and it's got links and things in there. Well, okay, so this is a thing. As a matter of fact, in our sort of process of writing these kinds of essays, this is something we need to provide as as an easy thing to do, because this is what we do in our own documentation. We are always doing this.
Yeah, it's impacted by this different style sheet, so we'll make a note of that.
Right. But so the point here is, what are we doing here? What we're doing is, this is not a piece of raw native code, because P and Q are sort of dummy variables. So we really want these to be italic, just like if I look up, the actual, and this probably should be a link here. And again, that should be something that's easy to get to. But let me just show you what I mean here. If I go to the page about and, what we'll see here, let me go to a different page, which isn't quite so, well, this is okay. Okay, so the point is that is in the code font. But oh gosh, this is a silly page to look at. Let me look at some other page. So something like this: nest and the brackets and the commas and so on are in the code font, but these fx per n are an italic font, indicating that they're kind of dummy objects where you can fill anything in there. And we need an easy way to do that for these essays. Okay, let me keep going though. So I'm going to just sort of hack this font here. But this is something that should be part of the sort of exposition making palette or whatever else, or possibly even this is something. Yeah, I don't know exactly how to get to it. Okay, a basic example of a Boolean function is and. Alternatively, let's see. Okay, is the standard logical operation logic operation and essentially let's see, the value of and let's see, the thing I'm grappling with is if I say and doesn't represent both P and Q are true. Ethan is asking, why aren't you using the essay notebook template? That is a very good question. And I'm embarrassed that we're not. Okay, here we go. Where is it?
Repository item.
This is absurd that we're not using this. Why are we not using this?
It's in the agenda that I made for this meeting.
And why am I getting some stupid error here? A string or task object is expected instead of $failed. Why am I getting that?
I don't know the answer, but I'll follow up on it.
It's kind of super annoying.
Yeah, not seeing that before.
I think I got it too, and there's some Packlet that needs to be updated, but I don't remember why or what.
You got it separately for something else?
No, exactly
But
here.
for this,
when
I think, yeah, I think that you had to do a resource update.
Exactly. Yeah, that was it.
Okay. That was a very good comment and good catch. And I really don't like the color of that heading, but okay, that's a different story.
Okay.
The sort of brown heading is kind of rather unattractive. All right, let's use our own dog food here. Let's correctly use this. Oh, what the hell happened there? I was copy pasting into that cell. What the hell did it do?
I think
That's
because
crazy.
I think I know what happened, and I
Yeah,
can
but it's wrong.
report it. Yeah.
I think I had the same thing happen to me when I used this also. I believe I reported it.
So it was a
Okay.
certain selection that did that?
What the hell's this doing? What's this doing? Come on, guys. You got to get this to work properly. What is this doing? Get rid of those stupid eyes and just make the thing actually work. Right? It's no good if that thing interferes with. It's lovely. Okay.
It's not the eye that's
Lovely and it's
interfering.
irrelevant.
It's not the eye that's
And how do I get
interfering,
rid of
but
it?
I can't get rid of it.
How do I get rid of that?
You should be able to select it and delete it.
Well, I can't. Maybe I can, but no, I can't. I can't delete
Okay.
it. So get rid of that. It should be deletable.
Well, we typically make things undeletable if there's structural requirements or things we
But
need
they're
to
not.
have.
I mean, somebody who's, I don't want to see something which looks like it's some analog of a trademark sign next to every single
Well,
thing.
okay, that was a design that was settled on some time back, but that's
But it's relevant for other kinds of things, but not for this. This is
Yeah.
much more of a narrative essay.
yeah.
Okay, so here, I don't know what the abstract is yet. I mean, the abstract could be this, but I don't think it is that. I'm really, these eyes are going to make me too annoyed. I don't think I'm going to deal with this.
Make you cross-eyed.
Yeah.
And we do have them on other forms, and maybe we don't on other ones, or you're thinking maybe just this one?
I think it's just this one, because you're writing narrative text. I mean, these other ones, you're writing small amounts of text as documentation to support something else. I mean, okay, so a thing that we're missing here is the ability to make this template input thing that is this mixture of something like this.
Right.
Okay. I mean, I would just lose all of these silly eyes here. In other words, because this is so much an ordinary piece of text. If you don't know how to write this, you are, up the creek, no paddles, no way to swim, nothing. Okay?
Yeah, I'm a firm believer in the linked example, explaining everything, or template.
I think
whatever.
so. Yeah, right. But I mean, the main point is this is like word processing. This is like a word processor. A word processor is not going to give you an information thing for every line you type.
Right.
I mean, it's very different from something where you've got a structured thing where there are 5 different kinds of things, and
where it's a form. This isn't really a form. It's
not a form. Right.
Okay. Well, these are easy updates to make and to pack that update, and then I'll talk with the team about what these documentation tools are and potentially updating the toolbar.
Fine. Okay. All right. So we didn't have an abstract here, and I don't know. Let's keep going a bit without an abstract, and let's see how we do here. By the way, Nick is asking, why is there no way to have an inline code cell inside a text cell? Yeah, that's actually a completely sensible question, right? Why can't you do that?
Are we referring to documentation structures again when you say
we're saying what Nick is saying is, if I say something like the cat nest fx3, okay, and now I want this to be, I want that, I want this thing here. I can make it be static styled text. Okay, but what I can't do is make that be an inline cell. That is, I mean, there's no technical reason why you can't have an inline cell here. So if I do a control param,
we have inline math cells, so inline code cells make perfect sense.
Yes, they do. And the point being made is, why don't we have those? Because if I do this here, this will be a math cell by default, right? But the question is, how would I make that be a code cell? And we should have that.
I can pass that along.
And possibly we can do it with some kind of shift. I don't know whether it makes sense.
I'm not quite sure what you mean by math cell. It is inline. It is box data. It is not.
I know it, but it's traditional
math.
form. It's traditional form.
Well,
it's traditional form.
No, inline math is not traditional form.
Okay, but it's got italic variables. It's got all kinds of stuff like that. Right?
Yeah.
And what we're asking for here is, I want to show something there that is a piece of code that I might type in, either with or without syntax coloring. Right?
Yeah.
And that's what we're talking about. And I think it'd be nice to have syntax coloring probably there, because I think there's no reason why you'd want to turn off syntax coloring. If you have syntax coloring for the whole document.
Well, again, with our docs, we do this. That's what the Control T feature does, so same difference really.
Yeah, okay, fair enough. Boy, Ethan is asking for something new and different that I've never seen before. He's asking for Grammarly integration for notebooks. Wowee. Pretty soon, you don't need a human to write stuff. You can just have the machine learning system you want.
Hey, Andre, why is inline math cells having the same font as the text fonts now?
That was a decision. We want, if it's inline to text, it should pick up from the text.
I hate it. I hate it. I've always hated it.
I know you're a guy who says math typesetting only uses one style of font, right? A certain type of serif look. I get that, but that's not the ultimate theory of how typesetting should work.
Yeah, but this, for example, will now use.
Oh, there is an ultimate theory.
there is a
Okay, is that
graphic.
using,
There's a
what-
graphic
sorry.
designers and book typesetters theory of how fontography works, but it, anybody who wants to bring their own math biases to it can have a different take. I can't argue with that, So, this is something that's debatable. It's something that maybe we're saying needs to be more easily configurable for people. Because when we say traditional form, we do mean about the way the constructs are put together, how, the actual structure of the typeset content is positioned and whatever. It doesn't necessarily have to imply, and it's typeset in something that looks like an old serif, font from books that.
Okay. Anyway, look,
there's
a bunch of stuff here about the ability to have inline cells that are themed for math, themed for code, and themed for this thing that we currently have inline cells themed for. And that's something we need to deal with. But we were, the purpose of this discussion was as much about content as about form. Okay.
Actually, a cute thing that we developed, which we haven't really used, is inline plots. So there is a theme called inline, and it literally makes a plot the size that you could have in a piece of text.
Yeah, well, I certainly put plots in text, and then I typically resize them by hand.
Right, and this does other things too. There's a lot of decorations in a full detail in a full-size plot. Inline.
It's not listed there.
Yeah, it's eventually. It's not one of the main.
It was not auto-completing. There's something wrong. It's not auto-completing there.
That doesn't mean it's wrong.
It's wrong. It should be auto-completing. If it exists as a plot theme, it should be auto-completing. Something didn't get connected between the auto-completer and the list of possible plot themes.
Just run it.
That's cool. I've never seen that before. That's very cool.
And it has the right baseline.
So if I take that and I put it in there, that's beautiful. Please, did somebody note down?
I noted it and I will report it. Yeah.
Okay, that's very nice, Roger. Well, maybe we'll get to use that in this essay. Not sure. Okay, let's come back to the text. Flippy is on live stream is making comments about digital gates and so on. Unfortunately, there's so many different words that I think implemented as an AND gate in digital electronics. Again, one has to be a little bit careful here, because if you have so much throat clearing here, people have forgotten what the point is before you actually get to say what the point is. Okay. In its simplest form, AND takes two Boolean variables, say P and Q, and oh God, horrifying that it's and here. We could use, to avoid this, we could use, okay, so the trade-off is we could use, or we're going to have the same mess here. But if we use NAND, then people don't know what it is, right? So I don't think there's any Boolean function which both isn't used as where people both understand what it is and where people don't use it as a conjunction in ordinary language. Anybody got any thoughts about that? See, okay, let me make a meta comment. This is incredibly typical in exposition, that there's this kind of puzzle. You've got, these different pieces, you've got these different objectives, and the question is, can you satisfy all those objectives? This makes sense to people?
Yep.
Okay. So, I mean, in this case, anybody got any suggestions for what to do here? Anybody here?
Yes.
We're here, we're watching, we're listening, thinking.
Okay. Is this okay. In simplest form, and takes two Boolean variables, say P and Q, and
with the value?
Well, I'm saying and determines whether, quotes, both P and Q are true. And its result, and it takes two Boolean variables, say P and Q, and gives the result. And gives us a result.
How about giving the result? I'm just trying to
but
have you avoid using the word and.
Yeah, right.
We get slightly more technical and say returns true if both P and Q are true.
Because then, well, we could do that maybe. No, but we haven't said true, unfortunately. We haven't given, because we've given several alternatives here for what these things are operating on, okay? Whereas here, it takes two Boolean variables, say P and Q, and see, one of the things that's tricky is it sounds like this only gives a result if both P and Q are true. Like if they're not both true, it goes off into la la land and does nothing, rather than it gives false. Well, okay, you know what? Maybe you're right, and gives true
in the case which both values are true.
Well, we could say if both P and Q are true and false otherwise. Not great. So it's two Boolean variables, say P and Q, and gives true of both and false otherwise. So now what we might do, I'm not super happy with this. So now we'd say,
might it help if even earlier we say a Boolean variable is either true or false?
See, the problem with that is, what you're building up to is a giant piece of throat clearing, which is the typical way mathematical stuff is written. And most people lose it before you get to the payload, so to speak. So in other words, you have to try and minimize the amount of, let's define this to be that. Let's define this to be that. I think we'll be okay with this, because what people are then going to look at is, let's see. So here, I'm not real happy with this, because I'm kind of wondering, what's tricky about what we're doing here is what we're about to build up to is something like and of P of or of Q and, Q and R or something, okay? The problem with that is that that's really a little different than just saying, Boolean table just defining a function by what is essentially, I mean, not to make it too I don't know, something like something like this, which is a representation of a Boolean function of 3 variables. And maybe we can say, I mean, here actually we could just say Boolean function, I think. Right. So at some point we can just give that. So what is the one for and? What is the Boolean? It is 1, 1, 1, 0, which is otherwise known as 14. If I'm not mistaken. What am I talking about? Come on, guys. Are you guys awake or not? This is obviously wrong, right? So that's and, right?
I don't know that there are other CA experts here.
It's not a cellular automaton thing. Anybody here who understands, I mean, you understand what's going on here. There's 2 inputs here. There's 1 output. True, true gives true. True, false gives false.
Sure.
Okay.
So yes, that appears to be a representation of and as 8.
Yeah. Okay. All right. Guys, if we're going to have so many people here, we need a little bit more interactivity.
So Stephen, do you think focusing on developing the text is the first step, or just coding and then based on the
write
coding?
the text.
Mm-hmm.
Because that's what's giving you. You just write a bunch of code, and then sometimes there'll be something where you have to solve a difficult code problem, right? And
well, I think what Maz is getting at is, do you flesh this out with an outline of all the text first and then come back, or do you stick with text?
You do it together. If you try and do that, it'll fail horribly. You have to write the whole knitted thing in one go. You can't expect to do, write all the text, then fill in the pictures type thing. The only thing that I do that with when I write is links. Okay, I do not put the links in the initial writing effort. Yeah. I go back for that, but everything else I'm doing in one pass here. Let's see. Okay, so this is difficult here. What to do here? Because the other thing we could do, which I think is a bit obscure, is something like this. See what I'm saying? Because otherwise this is in a sense too simple and it's hard to tell what's going on.
You could create a matrix plot of the values with all different true false things to demonstrate, or something like the rule plot could work and give a better example of all possibilities.
Yes, the matrix one isn't going to work well initially, because that's requires you to understand. I mean, if we make that, that's going to be an array plot of what is that? Is that Boolean table? What is the array plot? Roger, do you know? Roger, are you here?
Yeah. What array plot?
Yeah. So I'm asking you, what is the? Okay, so it's this, which is
the same. You're going to have to partition it. So if you go to Boolean function neat examples, or you'll find examples of that. But you basically have to build the matrix, and that.
Well, so maybe the better way to do that is to say table. See, the problem is, so first thing is, to get that into true false, we have to say bool of that, which is not, I'm sorry, into 1 0, we have to say bool of that. Otherwise we can't. Well, or actually the other way to do it, better way to do this would be the following.
Doesn't matter for array plot, but yeah.
Well, it will matter. We have to say color map, true color rules, true goes to 1, etc. True goes to black, etc. Right?
Right. But it will do something. I mean, it's sort of set up to deal with all kinds of crap.
Is it set up to deal with this case?
Yeah.
No, it's not. No, it's not. Okay, so let's look here. What we probably want is to say table and PQ, P, true, false, and then Q, true, false. Okay, now we would say array plot, but this is getting a little complicated here. True goes to black, whoops, color rules. True goes to black. False goes to white. And then we got yet another thing here. Then we got to say mesh goes to true. Okay. And that will be our multiplication table effectively. And what we might do here is to iconize that. And Nick is pointing out that in the function repository, there's a decently nice function that gives, let's see here. There's a decently nice function for truth tables here, which is probably doing what Wolfram Alpha does for a truth table. What's it doing? That's extremely elaborately complicated. I mean, it's kind of nice.
I like the 4th of July colors.
I'm rolling my eyes. Okay, so let's go back here to the problem of how we get started here, because the problem is, in my view, that is in a sense too simple an example, and it doesn't reveal what's going on. See what I'm saying?
Right. I think you need to show
I'm having a hard time. This is not particularly useful. I mean, I can just sit here and write this myself. But if we're doing this as an interactive discussion, we've got to have more interaction. Okay, so you understand the problem. The problem is if we give too simple a Boolean function here. Well, okay, so one thing we could do.
I sent in chat, and this is under applications for Boolean function, a way to enumerate all of them and plot all of them using array plot.
Yeah, okay, well, that's nice.
All 2 variables and all 3 variable functions.
Yeah, I understand. That's nice and worth having. Yeah.
And there's a similar, equally.
Yeah, I understand. I understand. I mean, that to me is a more advanced thing, because then what we're going to do is eventually we're going to show functional completeness of NAND and so on. Okay, but we're having a hard time getting started here. Okay, so because what we've got to explain is that one of these pictures represents all possible inputs, right? I have a slightly hard time with this because the word function, people will think algebra, calculus, whatever, and they'll think f of x. They're used to x being continuous variable. They're not used to saying there are 4 cases, x equals 0, x and y, 1 and 0. Do you get what I'm saying?
Why not mentioning that explicitly, like reminding the user?
But because then we just blew up the possibility that anybody who doesn't already know calculus can understand what we're talking about. Do you see what I'm saying? So you got to think about what's the dependency stack of the things you're talking about here. Right?
No, but a function is basically a table. The fact that we then show it as a table seems okay.
No, it's not a table. The person who learnt functions in calculus didn't learn functions as a table. Now, maybe they should have done, but they didn't. They learnt functions as, sin x.
Yeah, so they've learned continuous tables. But
yes, I understand. But the jump from a continuous table to a table is an unjumpable jump for most people. Right? So I think we might be better off. So what I was thinking is maybe we should jump directly into pictures and show things like this. But then I'm worried that see, I was thinking we would talk about f of x, but I'm worried about that because I don't think, like in my whole EIWL book about, elementary introduction to Wolfram language, I did not mention functions in the sense of calculus. F of x is sine x at all, ever. Because my experience and observation is people do not understand that stuff until they've done like pre-calculus or something. I mean, do you understand what I'm saying? I mean, maybe they understand it also from computers, from, a function definition. But again, people are kind of confused by that too. So, okay. Boolean functions. Well, maybe we can say, here is a pictorial representation of a simple Boolean function. Now, then what we would do here, which again, I'm not quite sure whether this is the right way to do it, is a folded up thing like this. The top row represents the input, bottom row, the output. Black squares represent true. White squares false. Okay, so in the first box, well, let's see. The top row represents the input to a Boolean function is a collection of values. So I'm defining the input to be the collective thing, not there are two inputs here. I could equally well have said there are two inputs here, but I'm not doing that. I'm saying there's input, which is the collective thing. The Boolean function shown here corresponds to is and. If both see, I want to get the word and. Here's what I'm struggling with. I don't want to say if both elements, what I might say, if both elements of the input are true, the result is true. Otherwise, it is false. Okay, I don't like that because I would really love to use the word and, since I said this is the and function.
Communicating that idea with code, isn't it easier just showing the code? Or
what is the code?
Just
and
for example, and yeah, that one, the simple one, yes.
No, we can show that next, but we got to say, how about if we did or? No, then we're going to have either. See what I'm saying? Okay, here's the hack. If the first and second elements are both true, the result is true, otherwise it is false.
We remove a level of confusion by, instead of using black and white, literally print the words true and false in the image.
Not a terrible idea. I think that image will be so ugly if we do that, though. And also the code necessary to produce the image will be kind of messy. I mean, we could do...
I was gonna get back to that truth table resource function. I think a lot of people are used to that. That something like that is gonna remove the necessity to explain.
Okay.
What is white? What is black? What's top row?
Well, okay, fair enough. Fair enough. There we go. Okay, fair enough. But then we've got to explain the P and Q notation there.
That you had it in a parenthetical.
I know,
note.
but I think that this is a rather daunting thing here. There's a lot going on in this image. Right. In other words, if somebody
and if you
sees...
say and if you change that to and P comma Q, is that going to persist?
You mean here?
Yes.
I mean,
Okay.
that I don't know what that did, but yes, I mean, the reason I say there's a lot going on in this image, okay? Somebody who is confronted with this image at the very beginning will, I'm afraid, switch off. Because understanding what's happening, I mean, this isn't super difficult to understand, but it's still, I mean, for example, I would argue that a better presentation here would have been to gray down the left-hand side so that you see the main event is just true, false, false, false. Am I making sense? Because otherwise cognitively, you've got basically, you've got your 12 boxes here, and it's like, what the heck's going on? 12 boxes, there's a thick line, there's a thin line, there's colors.
There's differing alignments.
Yeah, I mean, there's just a lot of weird stuff going on. And this is, yeah, I mean, as people are suggesting here, having a legend that says, true. I mean, I have to say, I don't think people get very confused by this kind of representation. And the point is, from this picture, it gives you the sense that you will understand it because it's a fairly simple picture. Now, we're then going down the path. So, by the way, Roger, if I take P and Q, so if I have a Boolean, a pure function, can I do this? Can I say Boolean function of the pure function PQ R, let's say P and Q or R. Does that work? No. Well, how do I do that?
How do you discover what number it is, or what do you mean?
Yes, that's what I'm asking.
Okay. Let me figure that out. Can't remember.
Okay, but I mean, so this is a possible approach that what we fundamentally do, it's a bit cellular automatonistic, but although, these diagrams, by the way, maybe I'm just so used to them after 40 years of using them that they seem totally obvious to me, but I've found in thousands of talks and so on that people do seem to get the idea of these diagrams fairly easily. And to me, you understand why I'm saying this diagram is much more appealing than this thing here. This thing here might be easier to explain. What's that?
Yeah, I agree. But then you need the text definitely to explain what that is. It's like specifying your notations. If you want to start with the notation and then explain what that is once, that's fine too.
Yeah, actually, I agree. I think you need something with the text at least first, and then you bring all the people along who aren't used to seeing it displayed as black and white squares.
Right, but I mean,
and I think
yeah, go ahead.
If you're setting up some guidelines, it wouldn't be bad to say how the notations should be set up right at the beginning. Maybe a section for notations would be nice in the template notebook.
Well, the problem with that, though, is if you say preamble notation, right? In this document, as we go forward with this, it's going to get, more and more things are going to happen, and there's eventually going to be fairly sophisticated. I mean, easy from the Wolfram language point of view, difficult from the traditional math notation point of view. As we start looking at, if you're suggesting that we have a preamble which specifies notation, I don't think that's going to work very well.
I was suggesting that. Now I agree. How about something like a side note that says, this is a definition of how we are showing the concept or how we are writing the concept? Some kind of an interleaved
Make a comment that in the set of all things we might write about, we picked one where this is uniquely difficult. Usually this is not a big issue. The reason this is difficult is because there's a collision of plain English language and the code and the math and what we're showing. It's all so simple that it's hard to tell what's going on. Now, it won't be as simple. As soon as we get to a function, even P and Q or R, as soon as we get to something like that, it's already much more understandable. See, the problem is, okay, in general, talking about Boolean functions, we're going to end up with two different branches. One is essentially the algebraic representation of Boolean function in terms of P and Q or R. In a sense, what we're going to do, what we're going to have to talk about here is the sort of the quotes, the formula representation and the tabular representation. Those are the two things we're going to end up with. And then what we're going to say is, given a tabular representation, you can always get a formula. And what we're going to say is, what elements do we need in the formula so that we can get all possible functions, i.e. all possible tables. And that's functional completeness and so on for, that's how we, how we get to functional completeness for NAND.
There's a properties and relations thing from Boolean function that gives you that. I pasted it into chat.
Okay.
That gives you the number, the index.
Oh, I see. That's an obvious way to do it with Boolean table. Yes, I get it. And Kevin is sending through.
Yeah.
Yeah. I mean, this isn't bad. This is a useful thing to show along the way. I mean, so again, what we're going to see here, and I think this is a feature of this particular example, is we're going to see 5 different representations of what's going on. And the question then is how many of them to show, because the thing we absolutely don't want is to show this one and this one and this one. And it's like, that's just total irreducible confusion. We got to stick to something, but we might be able to show 2, for instance. Okay, so we're probably going to have to wrap for right now in a moment, but you understand where we're kind of going is conceptually, right? When we talk about Boolean functions, they're really these 2 different ways of thinking about them: this formula version and the tabular version. Does that make sense to people? That is just the table of the truth table and the thing represented as f and P and Q or blah 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 blah. Right? So then a thing we're going to talk about is there's a formula representation, there's a tabular representation, e.g. in the formula representation, we can do the equivalent of algebra. We can do algebra, which happens to be Boolean algebra. Does this make sense to people?
Yes.
And, in the tabular representation, we can, well, again, there, the question is, if we want to, then we've got to say, when we implement in a digital circuit, it's like the formula representation. Where the functions are gates and the variables are effectively are like wires, but we have to say that more carefully. Yeah, so comment from Eric about throwing in, you might want to use the wedge and the V and so on. Yes. I suspect we'll get the wedge and the V because we'll have a table at some point that just shows all the Boolean functions and the interpretation of all of them, which I think is useful. Super is saying here, I think you're underestimating people's ability to understand. If they don't even understand the basics, it's even worth trying to explain to them. Yes, I think that if you do it, this is the trick in explaining. I mean, I humbly consider myself pretty good at this particular thing. Of being able to find these paths that allow one to explain really quite complicated things. You know, the challenge in explaining complicated things without losing people who don't already have, you know, some fraction of the knowledge. There's two challenges. One is you can end up, you know, getting to the point where you explain to the 5-year-old how to do, you know, certain pieces of calculus, and yes, you can make it work, but it's incredibly fragile. That is, you've ended up with, you know, this tiny path from what you can explain to some result, and as soon as you perturb that path, it's like total lack of understanding. The trick is to give people, you know, a reasonably robust understanding, which makes use of, and this is the challenge, it is very minimalist. It makes use of as few concepts as possible, but on the other hand, it has to put its feet down in concepts that people understand. And one trick here, which we're sort of using here, is there are terms that people have heard of, like digital electronic devices. What is the definition of that? Not everybody will know the definition of that, whatever it might be, but it kind of gives some theming background to what on earth we're talking about here. And clearly, you know, there's a good guess that, I mean, somebody might have sort of heard of a Boolean function, but only have a very vague sense of what it is. I think so. Anyway, I mean, I think it's let's see. Okay, we got a couple more comments on live stream here from Dan. Digital circuit representation, I think, will be illustrative as a direct application of Boolean algebra. Yes, I mean, yes, but you got to understand wires. You've got to understand. See, the problem with the Boolean circuit, I mean, yes, you can use the circuit as a piece of data flow. You cannot use the circuit as a representation of voltages. In other words, a data flow thing, which shows, you know, essentially the graph that shows that this, I don't know how we would generate the graph from this. How would we generate the graph from this? You know what I'm saying? It's like, in fact, here's what we could do. We could just say expression tree. And we'll have essentially, I mean, that would probably be a useful representation at some point to show here that is, and that's, let's see. I mean, the problem is, okay, so the difficulty here is, let's say this was, you know, R and P, for example. We'll end up with this, where those P's are the same P, so to speak. And whether that's explainable or not, I'm not sure. But, you know, I think we'll be able to get a fair distance. I mean, my guess is we'll be able to get Boolean simplification. We'll probably be able to get satisfiability. We can explain that. We can explain functional completeness. I would predict that we will be able to explain all of these things at a below pre-calculus level. And, but on the other hand, the other thing one's got to do, you know, the real trick in a lot of these explanational things is, how do you give an explanation that doesn't have the people who already know it just sort of falling asleep, rolling their eyes, but nevertheless not lose the people who don't already know it. And so, and also not have the people who already know it be like scratching their head saying, that's a really weird way to explain this. But I think by things like, what you want is the people who already know it to be like, oh yeah, that's a nice way to explain that. Without just being, oh, I'm bored. And preferably to say, oh, that's a nice way to explain it. I'll use that way to explain it next time I have to explain it to somebody. And Ethan is suggesting that we ask various experts to do this. Yeah, it'd be interesting to do. I mean, look, this is okay, we're going to have to wrap up in a moment here, but and we will continue this at another time. And I was just not at all prepped for this particular thing. And again, we should continue it in an unprepped way. I think perhaps it's useful for those who are, I do realize as I try and explain how to do this one, that there's an awful lot of different things you have to juggle to make one of these expositions work. And perhaps that's why these are not as easy as, I kind of think of them as quotes easy, but I know that in this intro, it will take me like 15 minutes to get a reasonable intro to this thing. At the end, I'll probably have a pretty reasonable intro where, again, the real challenge is, can you absolutely minimize the number of concepts you need to use, but nevertheless give enough sort of attachment points to things people already know and mentioning words people already know, so that they're not like, what on earth are these people talking about, so to speak. So anyway, so RBS is commenting, you can use tap water that flows down tubes and show logic operations like that. Right. That's like fluidic logic. And I think a good thing to do in sort of the one section here will be to say, what are different implementation forms? And you can talk about fluidic logic. You can talk about, okay, so there's stretch things here like reversible Boolean functions and so on. What we'd want to do is show a really complicated Boolean function and show what it corresponds to in terms of its multiplication table, its a bunch of different things here. This is actually, this was a pretty good choice of a topic, because it is difficult because it is so comparatively elementary, yet it accelerates quite quickly out of the purely elementary. And my claim is that we will be able to carry people along even if they're only at the pre-calculus level. We shall see. All right, any other comments as we're just to wrap up for today?
If not, I gotta go.
Yep. All right. Okay.
Thanks.
Thanks to everybody.
Thanks.
Thanks to folks on the live stream. We will continue.